Now, to just kind of wrap up this qualitative discussion on titration curves, what if now we flipped this and we started with a weak base and we add a strong acid to it? Okay, I won't draw the picture. I'll just indicate, right, that we're adding, drip-wise a strong acid to a weak base. And of course, as you can see, we would start with an alkaline pH. We still have this buffering effect window, but now it looks like it's a mirror image of the weak acid curve. Okay, so the weak acid curve looked like a shoulder. This kind of looks like a saddle. And now you notice here with weak base strong acid titration, our equivalence point is acidic. Our equivalence point is less than 7.0. And why is that? Well, once again, if we imagine starting with our weak base and we're adding strong acid to it, we know that that's a complete reaction. That reaction is going to go forward all the way until we've completely run out of both base and H+. So once again, if we had 1 mole of this and 1 mole of this and 0 of this, then all of this would react, all of this would react, and now we would create some amount of my conjugate acid. Okay, so that zeroes out, and now I've got 1 mole of this. Well, so now why is this equivalence point acidic? Well, that's because now once I've made this BH+, this conjugate acid of my weak base, this can now go through another equilibria reaction. And in this case, it just releases now more base and H+. And so thus we've released more H+, which is why our equivalence point is acidic. Okay? So once again, we remember that this H+ right here is what we were adding. We hit the equivalence point, it completely runs out, and now this is a new source of H+ coming from our base conjugate acid. Okay? And so all of those other details that we described, such as the half equivalence point, we would see the same thing with our weak base strong acid titration. So we could now say the pH equals the pKb at the half equivalence point. Okay? Because remember now, if this was our 50 mil half equivalence point, our 25 milliliter half equivalence point, as you can see, is in the basic pHs. And so that's why the pH will equal the pKb at the half equivalence point. Okay, so then in the next series of videos, we're actually going to keep doing the stuff on titration, but we're going to get into these calculations.